Is finding your dream career feeling impossible right now? You're not alone. Welcome to Career Blueprint, the podcast that helps you figure out your next career move. We explore the trends in tech shaking up the job market, giving you the unfiltered advice you need, whether you're starting out, changing direction, or guiding someone else. Let's figure out what's next for you together. This is Career Blueprint. Have you ever had a dream job? You know, the job you wish you had, the job you dream about. Maybe it's being a movie star or a professional athlete. Or maybe your dream's a little more attainable, like being a doctor or a chef in a restaurant. Or maybe you just dream about working for yourself and being your own boss. For many, being a software engineer is their dream job. For almost 30 years, being a software engineer has been synonymous with earning a high salary, well into the six figures. It meant stock options in a fast-growing company with a chance of becoming a millionaire. It meant free lunches and beer at work. And it meant doing work that's important, work that's changing the world we live in. So what's not to like? And this awesome career path was open to people right out of college. You didn't have to work 20 years and earn seniority before you could get these great perks. You could get all of this right out of school. Now, hold that picture in your mind, because that dream job we just talked about is getting completely rewritten by artificial intelligence right now. If you talk to today's software engineering students or to recent grads, those who are just entering the job market, their reality is really different than the picture we just painted a few minutes ago. Today, software engineers are entering a job market where they are ground zero for every AI-driven change in the workplace. AI is rewriting how they do a lot of their job, and these changes are prompting many to ask, is software engineering still a good career? Let's dive in and find out. I'm Carey O'Connor, and this is Career Blueprint, where we make sense of work's shifting landscape and help you understand how those changes may impact you and your career. Now, to understand what's happening today in software engineering, it helps to take a quick step back and understand a little history about the profession. And for those of you who've been listening to me for a while, you know I like to talk about a job's history because history helps us understand and put context around what's happening in the present. And it helps us predict the future. And that's definitely true with software engineering, which has gone through lots of boom and bust cycles. So a little history. Being a software engineer is really a new job. It hasn't been around all that long. When the very first computers were invented in the 40s and 50s, software engineering was a niche technical function that no one thought about as a career. It was just something mathematicians and electrical engineers did on the side, but it wasn't their main job. Software engineering really became a profession, something that people did every day for work in the late 80s and 90s, when personal computers and the internet went mainstream. Suddenly, everyone had a computer at work or at home, and everyday life started to become digitized. As this digital revolution accelerated through the 1990s, we hit the dot-com era in 1995, which was the height of software engineering as a career. This was the good old days. Investors were throwing money at any business with a .com in its name, and software engineers were kings. Companies like Google, Amazon, and eBay were hiring software engineers by the handfuls, and because they were so desperate for talent, they were offering crazy pay packages to anyone who knew how to code. Back then, you didn't even have to have a college degree. Software engineers were getting million-dollar stock options, free food, massages, nap pods, and their offices looked like playgrounds. Now, software engineering in the 90s was one of the most exciting and highest paid jobs in the world at that time. And all of this came to a crashing halt in 2000 with the dot-com bust. A bunch of startups that didn't have financially viable business models went bankrupt, and over 200,000 tech workers were laid off. It was ugly. But over the next couple of years, the tech industry reorganized itself, and in 2004, just a few years later, Web 2.0 emerged, which caused the tech industry and software engineering to enter yet another boom era. Remember Web 2.0? That's when we shifted from having an internet with static pages where people visited websites to view content to where we are today. Now we have dynamic, interactive platforms like social media where users engage with each other and the users create content themselves. Companies like Facebook and YouTube were just taking off then, and software engineers were back in high demand. In 2008, there was a temporary slowdown for software engineers during the 2008 and 2009 financial crisis, but things picked right back up as mobile phones started gaining popularity. Remember, the first generation iPhone came out in 2007. So it wasn't that long ago that our cell phones were just phones, not the mini computers they are today. By 2010, smartphones were proliferating and every company wanted to host their content on an app rather than a website. And just like that, we were back to a boom for software engineering talent. The demand for coding talent at that time, around 2010, was so high that software coding boot camps emerged, which promised that you could learn to code in as little as 8 weeks, and you could land one of these golden ticket jobs. You no longer needed a college degree. Software engineering continued to be a great profession over the next decade, with the pandemic in 2020 accelerating demand for engineers as everyone had to move their lives online. But things began to quietly change in the summer of 2021 when an AI-powered software called GitHub Copilot was released as a technical preview. Now, just a little background. When software engineers design software, they frequently work in groups, so they need a way to merge their changes into a shared code base and to know who did what and why in case there's a mistake or somebody has a question later. That's what Git and platforms like GitHub are for. Git is a version control system software engineers use to manage source code and other files during software development. It allows them to track who made what changes and when they occurred. In very rough terms, it's like version control in Microsoft Word. GitHub is a cloud-based platform where Git repositories are stored. So back to our story. In June 2021, Microsoft released its AI-assisted coding tool in GitHub. They called it GitHub Copilot. Now, it started as an innocuous helper for software engineers when they were coding. Its main feature was that it would offer autocomplete suggestions. So while an engineer was writing code for a software program, Copilot would read the surrounding code and suggest the next line or even an entire function. As software engineers started using this innocuous helper tool, it spread like wildfire. By 2022, just 1 year later, GitHub Copilot had over 1 million users. At first, these tools were great. They handled the boring parts of the job and let engineers move faster. But over time, something more structural began to happen as these AI tools got smarter and as software engineers learned how to use them and to trust the results. The engineers began giving GitHub Copilot and later its competitors like Cursor and Replit and more, they started to give them more and more responsibility. Instead of just having AI Copilot autocomplete a few lines of code, they started asking AI to do all sorts of things like fix software bugs and write entire boilerplate code for a new service. They started asking it to explain unfamiliar code and another engineer may have created. Basically, they began giving these AI coding assistants the work that they used to give to junior software engineers. This is the evolution that we're starting to see happen in all sorts of jobs with AI, that the work of junior employees is being given to AI systems. But because software engineering is a profession that it's such at the forefront of technology, this change is happening faster here than in almost any other profession. Right now, software engineers are actively experimenting with AI coding tools to figure out how to best work with them. Last year, a lot of engineers started talking about doing something called vibe coding, where they let AI handle almost all the coding for a project. So instead of the engineer writing software code line by line with little help from AI, the engineer would just turn over coding responsibility entirely to the AI coding assistant. They would write in plain language in a text prompt what they want the final product to do and what they wanted it to look like and how to function. And then they let AI do the coding. The engineer then iterates with AI, again, just using natural language prompts, until they get the product they want. You can see where this is leading. If you no longer need to know how to code, does anyone even need to know coding languages? And if you don't need to know coding languages, do we need software engineers? Well, the short answer is yes, we definitely still need software engineers. And we need them because coding is only a part of their job. So, what do software engineers do? Being a software engineer isn't about writing code. It's about solving problems with software. Coding is only part of their job. Before an engineer even thinks about writing code, he or she has to first understand what problem are they being asked to solve? What's the mission? And then once they have that vision, they need a bunch of technical information. They need to know constraints, things like budget and timeline. They need to know system requirements like the software security or reliability features. They need to understand what the end result is supposed to look like and how it should function. And they also need to know how the software is going to integrate into an existing system architecture or interact with other software. The questions go on and on and on, and this information isn't usually given to a software engineer in a neat, organized package. Part of their job is to figure this stuff out. So the first thing a software engineer has to do on any new project is ideation. Before an engineer even thinks about writing computer code, they have to ask tons of questions. They have to test out ideas, speak with product managers and business operations and user specialists and others. They have to really understand what the end result is supposed to be. And through this ideation process, AI can be a sounding board to a software engineer. It can help them out by brainstorming options or organizing their thoughts. But AI can't sit in meetings. AI can't resolve conflicts between different departments. It can't interpret somebody's vague comments on what they want to achieve. And AI can't decide which trade-offs make sense for the business. That's the heart of what a great software engineer does. Now, once a software engineer understands what the mission is and has the constraints and the technical requirements, the next step is the architectural design, where the engineer creates the blueprint for the final product. Similar to ideation, this process can require a lot of decision-making, particularly if the software is complex or novel, or if it's going to interact with existing system architecture. Engineers have to make tons of trade-off decisions like speed versus cost, flexibility versus simplicity, security versus convenience, because you can't maximize everything at once. Making these types of decisions is frequently more art than science. AI can be helpful in system design, but it can't act autonomously, at least for now. System design requires a great deal of technical and human context that's currently just too hard to feed into the large language models. It's faster to just do it yourself. AI is good at helping to test out edge cases and failure cases to uncover problems before they exist, but it can't act alone without heavy human supervision. Now, once a software engineer has that architectural design, they finally get to the coding stage or implementation and execution, and this is where AI is currently shining. And this is where we can expect to see AI taking over more and more of the work in the near future. Last year, Microsoft CEO said that AI coding tools are writing around 20 to 30% of their in-house code. And Google leaders reported that it was around 50% for them. So AI has still not taken over all coding yet. It currently struggles with writing really performance-sensitive code, weird edge case stuff, or anything that's truly one-off and custom to a particular company. Like talking to some quirky piece of hardware or handling very specific business rules that only exist inside one particular organization. Now, these tools will get better over time, but they're still not there. The last stage of software development is maintenance, and this is where AI is also very helpful. When something breaks in production or a bug pops up, teams are flooded with logs and alerts and back and forth messages. They have to spend a lot of time just slogging through all this noisy information to figure out what actually went wrong. This kind of pattern finding, summarizing work is something that AI is really good at. So this is another area where we can expect to see AI tools taking over a lot of the work soon. To give you an example of how fast things are changing, Anthropic recently launched Claude inside Slack so engineers can literally ask Claude questions about error logs or incident channels right where the team is already talking to each other about the problem. To better understand how AI is and is not impacting software engineering jobs, I reached out to a friend who's a leader in the tech industry, Mustafa Ali. Mustafa currently works for Twilio, a cloud-based communications platform that enables companies to have texting and calling and email and video within their apps. Twilio powers things like Uber sending you a text during your ride, or you communicating with an Airbnb owner about your rental on Airbnb's app. Now, Mustafa leads Twilio's self-service program and product-led growth. This means he's an expert at strategy and product-led growth initiatives, but he still thinks like an engineer. He's an engineer by training with a master's in systems engineering from Cornell and a Bachelor of Science degree in electrical and computer engineering from Auburn, as well as an MBA from MIT. So he's really smart and a very nice guy. So, Mustafa, welcome to the show.
Appreciate the intro, Carey. I'm excited to be here.
So tell us a little bit about yourself and about your work at Twilio.
Yeah, I think you mentioned a little bit of that engineering background, and really I started my career as a software engineer. My very first paycheck, in fact, was for a website that I built back in high school. It was a website for software engineers to learn to do coding, and this was in the late 90s. I put ads on the website and got my very first paycheck from DoubleClick, which is now the ads business for Google.
How old were you?
This was actually when I first started it. This was 7th and 8th grade. I was about 12, 13 years old.
Wow.
And imagine this is the 90s. It's like the Wild West of the internet. Nothing is mature at this point. Google was barely coming out. Yahoo was the directory. And there's a lot of experimentation going on. I feel like in some ways we're in a similar era all over again. But, very nascent, but just the excitement of being young. You don't have your full-time job yet, but you're getting a paycheck from people who probably don't know how old you really are. It was kind of exciting and got me a bug to experiment and build more products, and that was really the start for me. So I've worked as an engineer, I've worked as a product manager, I've worked as a go-to-market strategist, and like you mentioned at Twilio, I'm leading these initiatives where we're looking to drive a really great customer success and an inflection in the company's growth and doing innovative things like using AI by ourselves. So even though we build products that others can use to build AI products, we're also using AI by ourselves to deliver better customer experiences and also become more efficient in doing that.
Well, tell us a little bit about some of Twilio's AI integrations and how it's using AI in its business.
Yeah, so so AI pops up at Twilio in a few different layers. So definitely there's the back end where we use machine learning to detect fraud or improve the delivery rate of messages or the quality of voice calls, deciding in real time how to deliver really world-class communications and to keep fraud out of the system. On the customer side, we have the sales AI agent that's helping customers onboard faster, troubleshoot issues 24/7, and in their own language as well. So it's something really exciting that we're able to bring that experience to customers, no matter where in the world they're located. And then finally, I would say we're also looking internally. We're exploring AI as a co-pilot for our engineers, for our product teams. In fact, we really made it a goal for no matter who you are in the company, you ought to be using AI tools in order and look for ways to do what you're doing, but and do it more efficiently.
So it sounds like Twilio is encouraging all employees to try to find different ways to use AI in their day-to-day jobs. Does that sound right?
That's right. So I think our IT and HR teams have done a wonderful job in encouraging that and not being a barrier to that. So quite the opposite. And that's empowering every Twilion to have tools. Some of them will be just general tools, right? They're not task specific, but they're co-pilots that can, or kind of these LLM tools that can help you make sense of large amounts of information or be more efficient in getting through a particular workflow that you're doing.
So it sounds like for Twilio, it's more about using AI to augment current jobs versus replace current jobs.
Definitely. Just to give you an example, yeah, I think understanding how AI is affecting these roles, we have to understand customer needs because I think everything starts with the customer need. That sales AI agent, for example, that I talked about, right? They're new customers who want to learn the product, onboard, and we're able to give them that 24/7 experience in their language if they choose for their particular use case. And delivering that experience, personalized experience, was traditionally only possible if you were the largest companies in the world with massive, massive teams. So AI lets us achieve the scale, which I think is a net positive for customers. It didn't eliminate sales reps. It changed where human time goes, which is more complex customer problems, relationships, making judgment calls, as opposed to some of the repetitive work or really simple questions that would be popping up, which don't necessarily require a human to be answering for the 9,000th time.
And that's one of the positive themes we're hearing about AI is that it can take over some of the less great parts of a job, repetitive tasks that can be boring. And it sounds like that's what's happening, at least in many jobs at Twilio. Some of the repetitive, more boring tasks are being taken over by AI, while some of the more interesting things of solving customer problems are still available for humans to handle.
That's right. And I'd say, everybody's learning. I think anybody who says they've kind of figured it out, there's just so much changing every week that I regard ourselves as just on the journey. Even for software engineers, the shift from writing every single line of code to solving higher order problems in less time. In some ways, that's always been there. I remember. Heck, I remember assembly coding as well. And, you have kind of C, C++, then you've got libraries that you can use. So you have to write less code from scratch. You're not writing a sorting algorithm. You just use the sorting algorithms available in your library. So we've always had higher and higher orders of abstraction. And I think what we're seeing right now is just another level of abstraction. The ways in which it's different is, uh, you were still fundamentally coding. You just have to write fewer lines of code. What we're witnessing now is a more fundamental shift where you can offload entire tasks and the AI will come back to you after some period of time and say, here's what I did. And I think that's a pretty significant shift.
So you're talking about the role of AI coding assistants and how they're taking over at least part of the coding process. Are you seeing a time at any point where AI coding assistants might do all the coding?
Short answer, no. And I think maybe a corollary to this is are software engineering jobs getting eliminated? And I think the answer for that is also no. But I think what's changing is what it means to be a software engineer. Uh, or in some ways, maybe the expectations of a software engineer are going back to what they always were supposed to be. And maybe we went a little bit awry in the last 20 years. There's I think there was a shift over the last 20 years where uh, software, it was, as product management became more formalized as a specialization, it unintentionally created this separation between software engineers and customers. And you had kind of a product manager who's spending a lot of time talking to customers and figuring out what might be a good solution to these customer needs and prioritizing what should be built. And engineering, particularly at large companies, it became more about executing tickets and completing Jira user stories as opposed to understanding that user pain firsthand, feeling that pain firsthand, and problem solving in real time with them on what might be useful. I think that challenge was acute for large tech companies in particular. So, large teams of product managers, designers, researchers, they were doing a lot of the heavy lifting on that customer aspect. And I think it didn't help the profession of software engineering, which became more about, just coding and lead code and, how quickly you can solve these algorithm problems, which actually are very valuable because it sharpens, your problem solving skill set, but it became very narrowly focused on just the coding aspect rather than the customer aspect, which should always have been there. And I think the coding assistance is forcing us to ask, if a lot of the code writing is happening automatically, then, what do software engineers do? And, where software engineers do get stuck is that contact with the customer. And I think we're seeing that convergence of back to engineers being more involved with the customer.
And I think most people, not everybody, but most people would prefer the customer side of it and the problem solving side of it. If I'm trying to figure out a puzzle and solve a problem for somebody, that is probably more exciting on a day to day than just writing code over and over and over again.
Exactly. Though I think if you take a college student or maybe even a high school student who's applying for college and they're researching different, majors they could take or career paths they could take, and based on those career paths, what majors they should do, then they look at the curriculum for software engineering. It's just very, very technical skills and not as much of a focus on customer empathy, first principles problem solving, systems design. You kind of start to get more of the systems design stuff, in senior software engineering classes, but that's really not where the core of the focus has been. And I think that's been a little bit of things became a lot more vocational as opposed to human judgment and problem solving oriented.
So it sounds like at least some of your advice for somebody starting out might be make sure you're finding a well-rounded program that's going to teach you every aspect of a software engineering job, not just the technical components, but also the customer components, the critical thinking components, problem solving, and things like that.
Exactly. And a lot of colleges, a lot of universities, even a lot of coding boot camps, I would say. Coding boot camps may be very narrow in terms of the particular skill set that they're helping students bootstrap. But for a lot of colleges and universities, there are electives available. So, students don't necessarily need to look for a very narrow program, but for whichever program, if they're already in college, it's really about looking for those electives that can help them develop those skills. So, I mentioned systems design as an example. There are often courses in electrical engineering that are a lot more focused on systems design and higher order thinking and problem solving that can be valuable. I would even go so far as to say some of those liberal arts humanities classes that sometimes engineering students are not very excited about taking actually go a long way in helping synthesize large amounts of information, having a perspective about what they're reading and what they can glean about the writer from what they're reading. And those are skills that product managers tend to develop as they get a lot of reps as a product manager, as they become more senior as a product manager. There's really no reason why we can't develop, get reps on those while we're in college and be better positioned for these engineering roles, which are going to have less focus on can you write the correct line of code and more of a focus on can you have customer empathy and think about the right problem for the customer.
So another challenge many folks have, particularly if you're already in the profession, is AI has come on the scene and you may or may not be fully trained in it. You may be AI curious. What are some things that you would recommend to somebody who has maybe 5 hours a week to invest, but wants to improve their AI knowledge? Would you recommend they spend time learning AI tools, focusing on fundamentals, maybe building out their portfolio of side projects? How do you recommend somebody just spend, if they just had a little bit of time and they wanted to increase their knowledge and their marketability in AI as a software engineer?
That's such a great question. And, somebody who is already a software engineer or in an adjacent field where they're doing some coding, what do they do? And I think there's no substitute to just doing it. There is a lot of tools. We were, earlier chatting about Anthropic Cowork, GitHub Copilot. You've also got even more, generalist tools like Replit and Lovable. There's a lot of tools out there that less technical people can use to build. I think those are actually really useful tools for software engineers as well to be able to, build solutions and kind of see, what did this AI generated solution look like? And they can ask questions about, why things are implemented the way they are, in addition to just kind of, understanding the code. So I think a lot of learning could come from simply using these tools and seeing what they're doing, which if you take on one hand, I would say there's increased competition for a software engineer because all of a sudden a designer or a product manager or any domain expert can suddenly build an app with a description. Hey, can you build me an app that can, track budgets for my industry with these features? And boom, it creates something. But someone who doesn't have a software engineering background, who does that prompt, they'll get a little bit, further along the path and create like maybe a functional MVP, minimum viable product. Chances are they'll get stuck because that is not built for scale. But a software engineer, giving that exact same prompt and having the ability to kind of look at the code and see what what GitHub Copilot did is actually really powerful because then they're increasing their velocity, but they're also able to say, I see what the code is doing. Here's where I want things to go. What do I need to do next? Which is something that a non-technical person would not be able to do.
So, with your own path, if you were starting over today, would you do anything differently?
That is, I think I would personally not do anything differently, which was I studied engineering and took on an engineering role. Um, but I had kind of, these other classes that I feel like went a long way to helping me kind of develop a well-rounded skill set. Maybe one thing that I would do differently is I learned I was an engineer through and through, very technical. And it was really, as I was doing my master's, I was doing my MBA, where I got a lot of exposure to business problems and, how do people in finance think? How do people in marketing think? And I think that was incredibly valuable, not just in terms of the hard skill set, but understanding how other professions that I encounter at a tech company or just any company, what do they do? What do they care about? How do they think? And I think if I had that knowledge earlier, I would have stronger empathy for my colleagues and be able to translate what I'm doing into a language they can understand more effectively. So I think if anything, I would have maybe taken more of non-technical courses when I was doing my undergrad.
I so appreciate so many of the themes you brought up today. The one point you just ended on of non-technical courses, and you mentioned earlier the humanities, and which leads us into liberal arts degrees. And there's such an interesting debate going on right now of, will AI kill the liberal arts degrees in humanities, or are humanities and the liberal arts the savior as AI becomes stronger and stronger presence in our lives? And so I just think that's such an interesting debate. I know I personally have an incredibly strong opinion that judgment and the ability to reason and question is going to become so important, and that those types of educations do prompt that type of learning and understanding. So it's fun to hear this. And thank you so much for coming. And I appreciate the advice that you have given to everybody and given to me as I'm learning more about this profession. Do you have any closing remarks or anything else you would like to say?
Well, Carey, I'm reflecting a bit on what you mentioned about how that judgment and the role of human judgment as these AI tools and systems and agents become more prevalent. And I'm hoping to maybe share a story if we have time.
Please do, please.
So I was playing around with, firsthand example, I was recently playing around with one of these code assist vibe coding platforms and building an app. And it felt like magic at first, right? It's like I said, build me an app that does XYZ, and it was generating the code quickly and spun up like a user interface in minutes and tied it all together. I could start playing around with the solution. I shared it with a couple of people. It was really exciting. But as I started to add more features, like people were saying, oh, what if the app could do X? What if the app could do Y? And I'm getting new ideas as well. And as I iterated by giving more prompt, just this disorder crept in. Like small changes caused unexpected bugs. The architecture became hard to reason with. Each feature made the system more and more fragile rather than more robust. And for me, it was a little bit like the second law of thermodynamics. Like if you don't actively nurture the system direction, the entropy starts to set in, and it really felt like entropy. It was just chaos. I just could not do anything more with this app, and that's where it really clicked for me that these AI tools are getting very good at generating code. They're getting very good at visual design, even drafting product requirement documents. And when you combine them, it does feel like magic. But they don't understand context, where the business needs to go next, or the accountability element.
Right.
Right. Like there are multiple ways to build this. I'm going to make a call and I'm going to do A out of options A, B, C, and I'm
Oh,
going
yeah.
to hold
Weighing
myself
choices,
accountable.
two tough
Make
choices, which,
choices.
yeah.
Exactly. Now I could tell GitHub Copilot, make this app scalable, and it might do something, but like, should I be using microservices, serverless? What kind of database should I be using? What is the cost versus performance trade-off? It might actually be the exact same product, but how you build it may be very different based on the goals that you're looking to achieve between performance and cost and scale and all of these different directions. And there's a AI tool can maybe give you pros and cons of each, and it might even say, I recommend you should do X. I think that human judgment to make a call based on imperfect information and, going by the gut and saying, this is the direction I'm going to take because I think this is right for my app or for my business. That's not really going away. So, vibe coding, code assist platforms, they certainly raise the bar. In some ways, they increase the competition because less technical people are starting to build. But engineers who can do that system design stuff and they can serve customer needs, I think that's going to be the most valuable combination.
I have to confess, to prepare for this episode, I played around with some of those software tools and I had the similar experience you had. I think I probably tapped out a little faster than you did. But the first few versions it gives you in response to your text prompts make you think, oh my gosh, this is fabulous. This is amazing. But you do rapidly hit the ceiling of knowledge and of problems and how to solve those problems and working with the AI coding assistants. Again, without your background, I probably tapped out a little earlier, but I had the same experience. So I understand. And when you take that into a professional commercial environment, that's important. It's really important that humans are there to oversee and to edit the work that these coding assistants are doing. And at least with the current technology state we're at, I just don't see humans going away in this profession. I don't see it. The world's time goes on and the technology is evolving quickly, so things can change, but not in the near term.
There's just going to be more problems to go solve.
Right. Exactly. Exactly. Mustafa, thank you so much for coming. I really appreciate it. I always love your calm advice and your thoughtful comments. And I really appreciate you joining the show today and sharing your opinions and advice with everybody. Thank you.
Thank you, Carey. Really enjoyed it. Thanks for having me.
To close out, software engineering is still a great job, but it's hyper competitive right now, and it's changing fast. And the engineers feeling this the most are those who are early in their career. Unemployment for recent computer science graduates is over 6% right now. That may not sound high to you, but it's higher than many other college majors when it's usually the opposite. We're all used to thinking about software engineers having guaranteed employment right out of school, and that's just not happening right now for everybody. The number of entry-level roles has shrunk as companies are favoring experienced hires. But as we heard from Mustafa, there are roles and jobs out there. It just may take a while for you to find the right one. So if you're a software engineer in the job market right now, and you're struggling to find something, know that it's not you. The market is brutally competitive. To increase your chances of finding something, make sure you have a really strong portfolio of end-to-end projects that show proof of your skills, things that solve a real problem, so employers know what you can do. In tech, it's not about what you know, it's about what you can prove you know. So you need that great, broad portfolio, and you need to showcase that portfolio on LinkedIn or other social media so employers can find you. Also, think about focusing on some niche skills to distinguish yourself in the market. And if you're not getting anywhere with the big tech companies, think about applying to non-tech firms. Companies like hospital systems, insurance companies, banks, logistics companies, many of them hire software engineers, and the competition to work there is just not quite as fierce. And if you're thinking of going to school for a career in software engineering, make sure you choose a school that integrates AI into your education. A lot of computer science programs still focus on learning to code as a primary outcome of the degree program. Higher education can just take a while to catch up with job realities. And knowing how to code just isn't enough anymore to get the job. You need to understand coding languages. But the real skill you need to have is knowing how to supervise AI as it codes. You need to understand how these tools work and be able to quickly spot errors it makes, and know when you can trust it and when you can't. And remember what we said about the other parts of a software engineer's job. You need to master the human skills that AI just can't replace. Skills like communication, so you can explain systems issues and trade-offs to non-technical people. You need to have collaboration skills, so you can work with different personalities and across functions in an organization. And you need critical thinking, where you learn to question and reason through problems. And most of all, you need adaptability, because you'll be entering a profession that is in a process of constant change. Thank you for joining me today on Career Blueprint. If you have a minute, I would love to hear what you think. Please leave a comment or a review and follow me on social media. And see you next episode when we talk about another AI technology that is changing the way we work.